The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Gaprogman-Taylor, and this is episode 51, Creating an IoT Hand with Clifford Aguis. In this episode, I interviewed Clifford about his experience in technology, a little about being a pilot, creating an IoT hand completely from scratch, from 3D printing the moving parts to writing the software for the Arduino boards and the accompanying Xamarin app, and what his hopes for the future of the project are. One thing to note. This episode was recorded at NDC London 2020. As such, the audio is a little less polished than I would have liked and is a little rough at times, but that was entirely down to my own post-production skills. Remember that the full transcription is available at the website, which is available at .netcore.show. The transcription for the episode was produced in collaboration with Productivity in Tech. I would also like to thank both Carl Franklin and Richard Campbell for allowing me to use their recording space, The Fishbowl, for this interview and the interview included in episode 48 with Dylan Beatty. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. Thank you ever so much, Cliff, for being on the show. I really appreciate it because we're at NDC. Everybody wants to go see all the talks and speak to everybody. So taking some time out to chat with me is
that's good.
I really appreciate it.
No, thank you for the invite. It's a great podcast. I've been going back through the back catalogue.
Thank you very much.
Yeah, it's good.
For some of the listeners may know a little bit about you because I've talked a little bit with a connection that we both share, Jim Bennett, about the IoT hand that you're going to show off here. But could you basically give us a brief introduction so that people know who you are, where you're coming from, that kind of thing?
Yeah. Well, I kind of left school and managed to get a job in engineering with Ford Motor Company. So I did electromechanical engineering and a lot of robotics and PLC programming, which is the controls, the machine equipment. I worked in the industry for some 11 years, left the car industry and become an airline pilot. And I now fly for British Airways.
As you do?
787s, flying them around the world. A few years after flying, it was early hours of the morning, jet lag somewhere in the world. I can't remember where it was, probably New York or something like that. And I was bored. There was nothing to do. There was, nothing on TV. I was literally bored. And I got my laptop out and just started faffing around. And I was like, you know what? I'll get back into doing this software. Like it looks, can't be that much different from programming robots and things like this. And I got back into it. I now do, besides flying, I do freelance .NET development, mostly in the Xamarin and IoT space, but I do the odd website and the likes here and there. And that's me. As for Handy, the hand projects, that came about back in, I think it was late 2016. There was news reports of a dad that had 3D printed an arm for his daughter. And I went to school to pick up my two sons, and Sharon, Caden's mum, Caden's who I'm building the arm for, was standing there. She's like, Cliff, you seen the news about the dad that's printed this 3D arm? And I was like, yeah, I have actually. And she said, could you make Caden one? You've got a 3D printer, haven't you? And, Sharon's not these people you say no to. So I said, yeah, of course I can. And off I went and fired up the 3D printer and off we go. To give you a bit of back story to Caden. Caden is now 15 years old. You can do the maths. He's now 15 years old. He's born with no left forearm. So he's got a little stump from his elbow on his left side and his middle two fingers on his right hand are missing. Just a birth defect. It's, it's not just him. There's many thousands of people around the world that are born like this, or more commonly, they have amputations due to things like meningitis and the likes. Sure. Which caused problems. So I went away and did some Googling, some searching, and found the projects, found the news reports. The design was open source. It was on GitHub, so I downloaded it and had a go at printing it. The printer I had at the time was woefully inadequate. So as all good developers, I went and bought a new one. So I got a Piezoelectric Mark III printer, which is awesome. I think it cost me about £850 at the time. They're now around 600, awesome printers. And started printing and printing out early designs, and they were okay, but they were biomechanical. There's no electronics in them. It was, it worked similar to the NHS claw that Caden already had, which is a solid forearm, and then basically a claw, a metal claw on the end, which activates by moving his other shoulder. He moves his right shoulder backwards and forwards, a bit of cable across the back of his shoulders, and opens and closes the claw. Which works, and he could do things, but we was trying to make it better. So we 3D printed this. It worked in the same guise, but it was a 5-fingered hand as opposed to a claw. Gave it to Caden. Said, yeah, Caden, try this. He tried it for less than 5 minutes, and he said, hate it. It's not good. It's horrible. I'm going back to my claw. And it was kind of, got chucked away. It lives in a box of broken dreams underneath my bench. So yeah, that's kind of where the project started, and it's moved on somewhat from there.
Okay. So, sure. So, there's a lot to unpack there. Like, I think we were talking earlier on, and you said, yeah, I printed a .NET bot. I'm like, hang on, wait a second. Dial back 5 years ago, 10 years ago, fabricating 3D objects with a printer is it's science fiction. And now it's like, I spent £850, which is obviously a lot of money, but I've spent this money on this device, and I can make a 3D thing that wasn't there several hours ago, or maybe 20 minutes, or I don't know how they work, but, so being able to just go, okay, I appreciate that you have this situation. Let's go print you a hand. Like, what?
yeah. I mean, it's still quite amazing that these printers are around. My first printer, a RepRap Mendel, is about 8-9 years old. And you look at that now and you think to yourself, wow, that's really, Heath Robinson. It's really basic, and it could just about print things. My Prusa i3 printer is about 3-4 years old now. And the new Mini that they've just brought out, which is a mini version of what I have, is $300. I mean, and it can print, as good as the i3, its bigger brother, and it's an awesome printer. 3D printers it's basically just like an inkjet printer. It prints out a page, and then it moves up the Z-axis by whatever you set it to, normally 0.1 or 0.2 millimeter, and then prints the next sheet of paper, and it just keeps doing that with melted plastic, and eventually you end up with a 3D object. So, some prints take, as you say, 20-30 minutes. Parts of the hands, like the palm section of the hands, is about a 9-hour print.
Wow.
And then it takes about 20 minutes to clean up and take out all the support material, pair of pliers and break it all out, which is quite therapeutic, actually. Just breaking it out. But yeah, it's, all the plastic, all the material that's used to make the hands, from the wrist upwards, it costs about £6. So the material is really, really cheap. You buy it in weight, so you buy a spool which weighs a kilo, and one spool is about £25 to £30, depending on, subtleties of the material. And, that'll print 2.5, nearly 3 hands. Wow. So you can talk, it's not a lot of money, goes into 3D printing. So it brings the cost base down dramatically. And that's one of the reasons behind the project, is the fact that, the NHS will provide you with an arm and a claw, and every few months, or every 6 to 8 months, you go back to the hospital and they remold your prosthetic limb, because obviously you grow. That's what children tend to do. And then he gets a new one, and it's too big, because they make it too big. And as the saying goes, don't worry, you'll grow into it. And he'll grow into it. And a few months later, it's now too small. Goes back and gets another one done.
Right.
This, the socket that we connect to Caden, is 80 pence worth of plastic.
Wow.
And takes about an hour and 20 minutes to print. So when he says, oh, this one's a bit tight, Cliff, click print. Yeah, 1 minute, mate. Go have a cup of tea, and we'll have some biscuits and tea and wait for it to come out. And there you go, there's a new one. Wow. So the turnaround time is, is quite quick. My aim with the project was to move it on. I love IoT, .NET and Xamarin. So I started looking at it and think to myself, well, I'm kind of invested in this project now. What am I going to do next? The biomechanical arm didn't work. So I did some more searching. There was a team called OpenBarnex that were developing open source under the Creative Commons license a hand, which was literally the wrist upwards. Fantastic device. Had a lot of open source people putting into the project on GitHub. It's still there on GitHub. And yeah, they had this all open source, even the electronics, how to assemble it and everything else. So I took that project, looked at it and started building it. But things like the motors, the electronics, the sensors, they were selling on a store, but they never had them in stock. It was never there. So, I waited 3 or 4 months for the controller board, and it just, it's out of stock. It's fine. Right. Well, I know how to do electronics. I know how to do software. I'll make my own. So I started searching around, found my favourite store, Adafruit, and looked at their boards, and they had a Bluetooth, it's called a Bluetooth M0 Adafruit board, which works on the AVR processors. So I got one of those, got their motor controller board, wired it all up on my bench, and literally an hour later I was moving the motors backwards and forwards. It was because the libraries that Adafruit put out are awesome. They're fantastic. Literally downloaded it, include this, open, close, and had the motors and thus the hand moving backwards and forwards. It's like, excellent, this is great. Wow. And those boards, instead of the board from OpenBarnix, which was £250 when they had it in stock, those boards were, I think the main microcontroller board was, I think, $26. And the motor controller board was $19. So you convert that into pounds, it's not a lot.
Yeah, it's like, 35, 40 quid, something like that?
Yeah, somewhere around there. Compared to 250 quid for a board that I can't actually get. Yeah. Fun story was the fact that, I accidentally blew up one of the boards and turned into a smoke generation machine a day before giving the talk at NDC last year. But the good thing is that these boards are available on Amazon. So literally Amazon man was at the door the next day delivering me a new board and saved the talk, which is good. But it means, again, that I've gone with a board that is around the world. You can get it. Yeah. They're made in New York, but you can get them anywhere in the world. And then I started thinking, well, you know what? I fly planes around the world. I've made this prosthetic arm for Caden, and, it's still a work in progress. There's still some bugs to iron out, some issues, mainly around connecting it to him and getting viable sensor readings that work. The actual mechanics of the hand work brilliantly, but the actual connection to the connection to Caden is the bit where we're still playing and trying to work out the best way of doing it. But then it's like, well, if you can buy a printer for £300, you can buy a spool of plastic, you can buy the electronics. The most expensive part inside the hand is the motors. They're about $60, $70 each. Made by Actuonics, a little mini linear actuators. You can build this thing, and you could probably, build the whole hand without a printer for less than £500. With a printer, you're talking £800-900. So less than £1,000, you can build an arm. That's your first arm. Yeah. Your next arm goes down in price. Of course. So there's no reason why. All this is on my GitHub. It's all open source. You can put the links in the show notes if you wish. Sure, yeah. And the idea is that I can fly around the world, and if there's somewhere that I go to on the aircraft that I fly that actually has a little sensor that wants to print these for local children or even adults, just size it up a bit, then I'll happily go along and help them, show them how to build it. It's not difficult. The problems I had with earlier versions of the soldering, there's some you need to be very dexterous with a soldering iron. I've now managed to remove those by using different connectors and finding ways of doing it differently. And again, I'm trying to make this as simple, cost effective, and as cheap as possible. So OpenBarnix, hats off to them. They made an amazing design. They've moved on. They now they've closed their store, and they don't iterate the open source GitHub anymore. I think its last commit was late 2017. They now have a company that are run, and for reasons known to them, they are running a company and selling these commercially. I don't intend to do that. I intend to, whatever changes I've made to the hands to fit the electronics, the motors, the changes I've done to iterate the design is all on GitHub. All, download it, use it, don't use it. Sure. Do a PR if you see something that I've done wrong in my code. Do a PR.
Yeah. That's the whole point with open source, right? You spot something that can potentially be done a slightly different way. You can go, hey, I see what you were doing. I think I understand the problem. Here's how I would maybe approach it. And then you can come back and say, actually, yes, but what you don't understand is that there's these considerations and stuff like that. And we all collaborate. We all make the product better. We all improve people's lives, right? Yeah. And that's It's one of the reasons I got into the business was I want to change people's lives. I want to make, maybe having the goal of making the world a better place is a bit lofty for just me, but make someone's world a little better is,
So, I mean, this project literally came out of the blue. It was, Caden's mum saying, "You've got a 3D printer. Can you help?" He's like, "Yeah, why not?" And, it's a project, my side kind of project that I pop back to and that, but the kids are involved, my kids, in the community where I live, are all interested in the projects. It's kind of, when Caden wears it and takes it to school, it's people are interested. The reason, obviously you can't see it on the podcast, but it's printed in black plastic with green highlights. And the reason Caden picked that colour was because I originally picked a kind of skin tone. Caden's like, "No, I don't want that." And it was like, "Well, why?" And he said, "Well, because people look and they're not sure, is it real, not real? They don't know." He said, "It's black and green." He says, it looks killer and it's sick. And, the words that, teenagers use these days that,
get that Fortnite branding on it.
Yeah, that's it. Yeah. And so for him, he wanted it to look different so that people concede that it's different. It's not real. It is a biomechanical arm. Sure. And that was for him very important. Some of the things that Caden's come back, and talked about, it's like, "I don't like this." It's like, "Okay, let's change it. Let's fix it. What can we do to make that different?" So it's all, coming around like this. And it's little things like, Open Bionics use a big, in their design, they use a big, the motors are powered from 12 volts. So they use a big RC battery out of a radio controlled car, which is big and heavy, but you need a specialist charger to charge it. You need, all these things to power up your arm. I looked at it and thought to myself, well, my board runs on 3.3 volts. So, that's quite low power. The 12 volts are the motors. I thought to myself, well, how can I want to be able to do this where actually I'm not a big battery pack. And I had some Anchor power bricks and I looked at it and I was like, what could I? Why not? So I did some research. Polyloo make these power boards and they do a step up board that steps up from, 3, 4, 5, 6 volts up to 12 volts. Oh, and it's a stable DC output. And I was like, well, will that work? So did some testing. It does. So I now use a normal 5 volt power brick that we all use to charge our mobile phones and transfer it up to 12 volts to power the motors, take the 5 volts into, it's 5 volt tolerant, the board, the Adafruit board, and power the board. So now I've got, rather than a big hefty battery, I've got a normal USB chargeable battery pack, which is fantastic. Downside is that when Caden wears his arm to school and his friend's got a flat battery, it's like, "Caden, can you charge my phone?" But there's ups and downs.
Give and take.
It's give and take on this. So, but it just means that, again, we've reduced it down to, if you can't get that power brick or that battery in wherever you are in the world, then you just use a USB power supply from whatever one you've got and just somehow tape it on.
Stash one in your pocket, run the cable up your sleeve.
Exactly. Yeah. You can see on the design, I've kind of Heath Robinson just stuck it in the forearm. That kind of works. There's other ideas we're having about how to do it in a little compartment. The idea is the fact that we make it with off the shelf cheap components that Amazon, eBay, Alibaba, wherever you kind of can shop around the world and get it delivered to you. So that got the arm working, and then obviously I had the Bluefruit, which is a Bluetooth enabled board, and it's like, okay, right. So the next step is the fact that I noticed with the Open Bionics hands and with other developers, companies that produce these, is when you have something that needs to be changed, settings, because you don't use the muscles, or Caden's never used those muscles in his forearm because he's never had to. He's now using them to tense, to trigger the action of the sensors, because they were never used, but now he's using them. They're starting to grow in strength. So now a small movement for him is now a big sensor reading. Sensors need to be adjusted. Things like the motors over time start to wear down, so they don't move quite as quick. They don't move quite as precisely. So you want to change the settings on those as well. So invariably it meant a visit back to the prosthetic department and get them, tweaked, tiled and adjusted. And I thought to myself, well, again, we can fix this. I do Xamarin development. We can build a mobile app. The advantage of it being Xamarin is the fact that it's, again, it's open source. Microsoft platform, it means that I can build this app such that it uses the native layer of the device, so Android or iPhone, and the advantage of that is the fact that if someone like Caden that has no left arm, has only got sort of 2 fingers and a thumb on his other hand, uses the accessibility options in his iPhone quite a lot to make the buttons bigger, that sort of thing.
Yeah.
And it's like, well, if I do it in Xamarin, I don't need to worry about how he accesses the phone because Apple take care of that, and Xamarin just step on top of that, and I've got my code running Xamarin on top of the iOS platform, and the same will work for Android. So the fact that I could do that, the fact that I can access the Bluetooth stack from within Xamarin meant that I built an app and put it together fairly quickly and had it sending UART commands, so basically serial commands, serial strings backwards and forwards in the hand to control the hands. And it's like, well, hold on, now we can start to get somewhere. So things like the fact that the hand has 7 grips loaded in memory that it loads from the EEPROM. And those 7 grips you cycle through. So if you think, your hand can only do 7 things, and you've got to select which one of those 7 things you want to do. And if you miss it, you have to go back around the circle to get back to where you started again. Yeah. And invariably miss it the second time because I missed it. Quick. Yeah.
Rotary phones,
yeah, exactly. So, chatting to Caden, he's like, I don't like this because, I keep not having the one I want. It's like, well, let's make the list shorter. Yeah, but now I want that one and not that one. It's like, okay, well, if I put that into the app, so in the app, you can select which grips you want enabled any one time. You go to another part of the app, you can select the order. I want it in that order, that one. One thing that has been suggested to me, haven't put in yet, is having grip sets. So that you can select, well, this is my set that I'm using at school. This is my set that I'm using at Scouts, because he's quite active in the Scouts. This is a set I'm going to use when I'm, gaming on my Xbox, that sort of thing.
Yeah.
And again, it's quite simple to do in the app. As the muscle sensors change, he can quite easily go in there and just tweak the settings himself. If anyone's listening to this and anyone is an expert on machine learning, please contact me. Because one of the things I'd love to do is work out, I'm not a machine learning novice, let alone an expert, is having machine learning learn the fact the sensors values are changing.
It's 9 o'clock on Monday morning, he's going to school, I'll automatically switch to the school set.
Even that's a genius idea. I never even thought of that.
There you go.
Timing, calendar system. Yeah, I was thinking more about the sensor is starting to see actually we're hitting the peak. We're clipping off the top of the sensor readings. Therefore, let's adjust the gain levels down. Okay. And because it's just a value, an arbitrary integer value, we can adjust those values dynamically. A way of learning, the app learning, have a little machine learning model that it will learn. Right, okay, we're now starting to clip, or it's too quiet. Let's put the gains up because maybe he's tired. And he's sleepy.
His arm's getting fatigued.
Exactly.
The movements and the triggering mechanisms. It's getting late into the day. He's a bit tired.
Yeah.
Or whoever's using it's getting a bit tired.
Yeah.
They're getting fatigued. Let's increase the gain or drop the gain because it's first thing in the morning. Or
So, it sounds simple. Us talking about it. But I have no idea how to get ML.net or whatever to make this work. I do know that you can run a machine learning model from within Xamarin, and you can do it, in the .net. I just don't know how to do it. So if someone's listening and they're, I'm on Twitter at Clifford Ages. Come and find me and see if we can help in the project. But
maybe you can shout it out during your talk as well.
I will. Tomorrow morning.
Talk to people as we're walking through and say, hey, do you know machine learning? Go see Cliff.
So so now the project is the fact we have the hands, we have the electronics in the back, and we have a power system that uses bog standard, in this case an Anker battery, but whatever USB battery supply you have. This is a 10,000 milliamp battery. It lasts him about 2 days, a bit less when he's friends and he's charging his iPhone at school. But it's it's good enough to get him through the day. And it's a small, lightweight battery that he can just have a spare in his backpack.
Exactly right.
The Xamarin app is almost to the point where I'm ready to start pushing it out to other people. I've tested it and worked with it on Caden, and little things we come up with. Little things that he's asked for is he's never sure which grip is currently enabled on the hands. So he says, can we not just have like a light on the back that changes colour? And this is like things I'm not thinking of, but as the user, he is. He's like, can I not just have a light? And it's like, okay, so we initially put a light on the back of the hands, which Openbionics do as well. They put an LED, a NeoPixel LED on the back of the hands. And he's like, no, it's no good because when I'm holding my hands,
Can't see it.
Well, the back of the hand is always facing away from me. Can not put it on the side. So the design iteration we've got going at the moment is putting it just where the thumb is, because it's left hand we're doing for him. So just where the thumb is. So you can just glance down and see the fact that you can nearly always see your left thumb. And the little LED strip there will give it a colour indication. So I've got on my bench, it's not here at NDC, but on my bench is a demo version of this. Caden was over last night and was having a tinker and a play, see if we can work out kind of some of the subtleties of it. And then within the app, I've engaged it such that you can change the colours of the hand grips. So their primary colours are red, blue, yellow, green, that sort of thing. So when he's selecting the grip, he can set the LED colour. So he will over time learn what he wants it to be, but there may be another child that, hates red. I don't know.
Exactly.
Or maybe they're colourblind, and for them it's a different sequence,
flashing,
that sort of thing. Exactly. But once we get it there, we can decide what we want to do. And again, it's little things like that you don't think about because you're so engrossed in 3D printing, in the power system, in the Xamarin app, and you hand it across and he's like, it's all right. And he'll never say it's not nice, but his mum was like, just tell Cliff the truth. If you tell him what you really think, he can then change it and fix it.
Of course.
And, the LED on the back was saying, it's all right, but it's not, and it's like, well, can we not just put it there? Yeah, of course we can. Let's do it. Let's make it happen. And hopefully, as I say, fingers crossed, we'll get to a point where we can have this such that, it's open source and everyone can get it. And then hopefully I'd love to see other people downloading and building these. If not, contact me and say, can you help build one? I'm more than happy to help anyone.
Awesome. So what about the circuit boards inside? We were talking earlier on, you were saying it's got a couple of these. I honestly don't remember the model numbers because they all came out really quick because, you're so, so like you were saying, you're so involved in it. Yeah. But you mentioned there's the Wilderness Labs one that you're looking into and things like that. And that's like low level, well, not low level, but that's .NET inside the ARM, is it?
Yes. That's the next iteration, as we... The next iteration is that we're going to take out the Adafruit board, which is running Arduino C, which is great. It's fantastic. It's not the quickest in the world. It does the job. It works. But there's things where we're either communicating between the hand and the app, or the hand is working. It's either or thing. I want to move across the Wilderness Labs. I've developed a F7 micro board, which is based on the Adafruit Feather footprint. It's slightly longer, but it's the same pin out, which means it can drop straight into the hands with very little work. And then it will run .NET. So I'll have .NET in the hand, .NET on the phone. And if this machine learning thing comes off, I dare say there'll be .NET in the cloud somewhere, run on Azure. And then we'll have .NET everywhere. And that isn't because I need to do it. It's because actually I'm invested in this project now and I'm enjoying it and it's fun. And it's like, well, why not? Let's try it. Let's see what can happen. And if I can get .NET into the hands, on a microcontroller board, that'd be fantastic. At the moment, I do have some Wilderness boards. The problem we've got at the moment is that, the Wilderness board's Bluetooth, stack, isn't baked. They're still working on that. I think it's beta 4, which they're releasing. I think it's March, is their timeline for releasing that. That way I can then start to link the phone and the hand together.
Sure.
Some of the, I2C, which is a serial protocol that the main controller board speaks to the motor controller board. I found some issues there, reporting back to the team. And they're aware of them. There were things they knew about. And again, they're things that are going to, bug fix in the next beta release. So hopefully come March, April time, we'll have a board that can do what I need it to do. And then I will bake it into Handy. Sure. And they will have .NET everywhere, which will be amazing. Awesome.
Yeah.
So,
you were saying earlier on about, you're showing this off to the potential users and they're saying, can we do this? Can we do that? And you're essentially doing the same thing, but with this Wilderness Labs board. You're saying, hey, I'm using it in this real thing. Can it do this? Can it do that? Well, it can, but it's coming soon, or this is broken. The exact same thing, right? The same things that you are experiencing with Caden is what they're experiencing with you. Hey, this person is doing this thing, right? And we're getting real live data because in our lab, we've only ever really poked it with a stick and it's kind of done what it needs to do. So does that mean then that the current iteration, presumably the device sat in front of us now, is low level C? Is it Python?
It's Arduino C, which is a version of C that's been kind of ripped up and large chunks of it chucked in the bin because it's not required, because it's a microcontroller. Things like your standard out and stuff like that, which would go to a screen, but there's no screen, so we don't need that. Chuck it away. So they've really stripped it down low level, but then they've added parts like the fact that on your computer, when you're running C, you don't have GPI output, like general purpose input output port. You don't have I2C, you don't have UART ports, serial protocols, that sort of thing. So they've developed libraries that do those functions instead. So it is C. It's a bit quirky in places. Anyone that's worked with Arduino will know. But it works. It does the job. The Adafruit board is awesome. Built and made in New York by the Adafruit Industries, and they're dirt cheap. And as I say, you can get them from anywhere. All the other electronics in there are simple cables, wires, and things like this. There's nothing, expensive or difficult or challenging in the build. The circuit diagram is as simple as I can make it.
Sure.
But yeah, we'll move hopefully across to .NET, not because we need to, but because I want to.
Simplify the whole thing, right?
Yeah.
If you're only using one language for the whole stack,
it's
the same reason we're getting Blazor in the browser, because if it's one language in the whole stack, everyone who's working on it understands it. It all becomes so much simpler to make a change, right?
Yeah. And not only that, it's C#, and a lot more people, understand and can read C#. They can read, C, and Arduino C is a little bit special in the way it does things sometimes. But and it means that, a lot of the code that's there at the moment can disappear, because quite a lot of it is kind of boilerplate stuff that you just need to do just to turn on an LED.
Sure.
Whereas in the Wilderness Labs C#, it's literally a line of code and it's done. The LED's there. It's, pretty simple stuff. So that's the plan, the future, for the project. I enjoy coming and talking at conferences and meetups around the UK. I've even been to Boston and given a talk. Wow. One of the night stops, come along to our meetup and have a chat. But it's purely because, to get some kind of ideas like you was talking about a minute ago for machine learning, 9 o'clock on a Monday is going to school, therefore put it in school mode. I've never thought that before. Not sure Caden had, but it's an idea that actually will probably make it to be in the app.
There you go.
It's good.
So then you were saying earlier on that there's this, I don't know the technical terms. I mean, I did do electronics, but this is more like the biomechanical. There's a tension that he provides in his muscles that's read by the sensors.
Yeah, we got some sensors in the socket that goes on the Caden's arm, and we started out with these MyoWare sensors that are just like your little sticky pads you have when you have an ECG with the doctor. And they measure electrical impedance and can then decide actually that muscle is being moved because we're reading. But they use the little sticky pads. You need 2 of the sensor boards. They're $35 each, so $70 straight away. The little sticky pads, you need 6 of them, 3 for each board. And a pack of 50 costs £5. So they're not expensive, but a pack of 50 is only going to last you, 8-9 days? And you're going to be out. So that's like every other week. Or, not even that, every week you're spending £5 on sticky tabs just to keep your arm going, which, is not a small amount, ongoing costs. So that was one of the early things I wanted to get rid of. Hackerspace magazine did an article about a year ago, not even that, about debugging Arduino. And as part of that, they used a little piezoelectric sensor. And I was like, Debugging Arduino was a brilliant article, but actually that sensor, what's that? I want one of those.
One sentence and a whole article.
It wasn't even that, it was a picture.
Oh, right.
It was literally a picture, and you could see the picture, and it was like, in the code, it was like taking the sensor reading, and it's basically a stress sensor, and it's used in drum and guitar pickups, and it senses vibration. I was like, oh, hold on. Well, tension of the muscle is just a low frequency vibration. It's, either on or off. So would that work? Back to my favourite Amazon postman delivery guy. And I got a pack of 10 for, I think it was like £1.80 or something. Really ridiculously low price. How Amazon delivered that free to my door, I do not know. But I got them, wired it up, and it worked. I was like, oh, this is cool. so we chuck out the $70 sensors and the £5 every other week sticky pads, and we've now got super cheap sensors. They worked. The difference is they can only sense give you a spike. So if you push it, you'll get a spike, but then no more output.
Sure.
And a piezoelectric sensor is basically, the buzzer that's in your PC that tells you your memory's bad and it beeps, 4 times for memory or what?
Something like that,
whatever it is. It's basically that in reverse. So you pass electricity voltage through your piezoelectric sensor or through your piezoelectric beeper, and it'll make a noise. If you push it, it will generate a voltage out, which is only a low voltage, but it's enough to be picked up by the analog input on the Arduino boards. So that's what it was. So you get a spike, which is great. You can actuate the hands and it works. But as soon as I give it to Caden, he's like, but it's not stopping in the middle now. I said, what do you mean, Caden? He said, well, before I could move it a bit and then stop it. And that was because the myoelectric ones, you could kind of control the motion, just like you can with your real hands.
Yeah.
I hadn't noticed that. I'd been working on this for a couple of weeks on my bench. I was like, I've cracked it. Genius. It's brilliant. It's fantastic. I give it to the user, and the user instantly picks up on the fact that this functionality that it had before had gone. I hadn't noticed because I'd been open hand, close hand, open that grip, do the OK signal, not OK signal. And it's like, he noticed it straight away. It's like, okay, right, back to the drawing board, we'll go away. But that then got me thinking about, actually, well, there's that out there. What else is out there? So, down route somewhere in the world, I was, Googling away, trying to find what I could find. And I found these force sensitive resistors, which give you, you apply voltage, and as you apply pressure, you get a voltage linear to the amount of pressure you apply. Again, super cheap. I think they're about £4 or £5 each. And they normally come in a pack of, a bigger pack, and it's even cheaper. So I've got some of those in different sizes, so we can try the different sizes. Couldn't wait to get back from a trip. It's like, come on, fly faster. I want to get home. Got home. There was the package waiting for me. Tore it open, went into my lab and evil genius time, and hacked away and got it working. And a day or two later, had it set up so that it works almost the same as the MyAware sensors, but they're a fraction of the cost, and they work great. The downside then that we're coming and we're still battling with at the moment is where the MyAware sensors stuck onto his skin, and they were there. So no matter what arm grip we had, the sensors were always sensing. With these, we stick the sensors on the inside of the socket, which goes, he puts his stump into.
Sure. And,
which means that sometimes the sensor's not quite in the right place, or sometimes, his arm isn't quite actuating the sensor, enough. And again, that comes back to the machine learning thing that I want to try and work our way of detecting that that's happening, and saying, actually, let's turn the gain levels and the peak thresholds and hold dwell times down to this level, because that's the readings we're getting today.
Or maybe if he's moving around a lot, literally moves around on the socket, and the readings aren't quite right because the sensors aren't quite where they need to be. Yeah. So maybe you could have an alert goes off on his phone. Hey, it's come a bit loose. Just rotate it a little bit.
Yeah, something like that. Yeah. So, I mean, that's where we got to. But, again, we've reduced the cost down. My aim, my dream that I'm, really want to get to is to be able to take the 3D printer out of the cost, but be able to literally buy all the materials and build one of these for less than £500. I'm just shy of 600 at the moment. There's some bits that I'm going to take out, which should make it a little bit cheaper. And a little bit easier to print. Some of the springs that are used inside are quite expensive. There's 3 of them that are on the end of the motors, and they're like £7 each. I'm trying to work out whether we can reduce those. There's a different motor that I found recently, linear motor, which is about half the price of the actuonic ones I'm using, but they're slightly bigger.
Sure.
I've got a couple of those on order. They're coming from the US, and hopefully I can see if I can fit those in, because then again, that reduces the costs. If we can reduce the costs and get better functionality. And the advantage of that one also gives you not only a potentiometer reading of where it is in its position, but it'll give you a current output. So it'll tell you the amount of current it's currently drawing, then for readings, you can then kind of work out, actually, I'm drawing a lot of current. Is it stalled because it's gripped something? and things like this.
And then presumably you could use that information for how much power does it have left?
Yeah.
Will it last until the end of the day?
Yeah.
Do I need to swap out the battery? Do I need to
exactly
plug in? That kind of thing.
Yeah, There's all those sorts of things. But again, as I say, it's got to a point where Caden can use it pretty much now. But it's now, well, what else can we do? What can we do to make this better? What can we do to improve on this? Like I say, Open Bionics have now got their product that they sell, which they've taken far beyond what I've managed to do. But they've got a whole team and a company behind them and funding. But they sell these as commercial products, and they're not cheap. We're talking in the many thousands. They're not available on NHS because the NHS deem them not,
it's too expensive.
It's too expensive, and they've got their hook system which works, and that works for them. But they are being sold in. I know there's people in mainland Europe, France, Germany. There's lots of people across the US. There are people in the UK, but they're getting crowdfunded to get their arms and stuff like that. Their hero arm, and hats off to Open Bionics. They've done an amazing job. It's phenomenal what they've done. There's one of me. I do it as a sidekick, and I started out doing this for Caden and his family just because why not? And it's morphed into this project which actually keeps me busy.
So, I can imagine. So then with the app, because it's Xamarin, presumably if the user wanted to switch to Android, they can just do that, right? Because it is just cross-platform. And presumably it exposes the same low-level systems, the Bluetooth and all that kind of stuff. And then if you needed to update the software, you can presumably download a file, open the app and go send this to the device, and it just
over-the-air updates is on the to-do list for doing over-the-air updates to the hand. But the way the Xamarin works is your .NET Standard project. All of my code is in there. I've made a point of trying to prove a point to myself that I do not want to touch the Android OS projects. I mean, they're there. They sit there in the project, in the solution file, but I really do not want to touch those. So other than pulling in NuGets that need to be pulled in, Xamarin Essentials and the ACR Bluetooth files that are pulled into all three projects of .NET Standard and the Android and OS. I have not written any code in those two platforms, so all of my code is in the .NET Standard and it all runs in there. I use Xamarin Shell to do the navigation, the layout, because it does the job. I got
drag
a flyout.
And drop button, it's there.
Yeah, it's
right?
done. And then I've got the separate pages, and all the Bluetooth comms is sorted with a open source library. So everything that's there that you can go and look at on the GitHub is all open source. Right. I literally, on the train ride in this morning, one of the things that was annoying me was I wanted a picker. To like a list view where you can reorder the list view, and I've been using Sync Fusion tools on a actual paying project for a client, and they're awesome, brilliant tools, amazing tools to use, and I've been using their reorder list view, and I've been using that in this project, and I was like, that means you got to have a license, and Sync Fusion do give away free licenses to open source projects, and I think it's amazing they do that. But it means that if you update the NuGets, you got to go and log in to get the new license key. Which means if I open source it on my GitHub and you download it, you've got to go and get your license key, which can be a barrier to some people. Some people that are new to .NET, new to programming, new to Xamarin, for example, it may be a bit of a, I'm not sure. On the train ride this morning on Twitter, I see someone, I can't remember his name, Alfonso, I think his name, French guy, lives in Paris, Xamarin MVP and the likes, and he's got this thing called Sharknado. And I'm like, what's that? I looked at his GitHub, and he's got a reordered list view. That's part of this project. All open source, all there on GitHub. So, at some point in the next few days, I'm going to pull in that NuGet, remove the Sync Fusion tool, Sync Fusion, and put in this Sharknado, which then means there's no licensing issues, and it's all open source.
Anyone new to the project just pulls down the source code, hits F5, and it builds, just works.
And it works. So at the moment, to get it onto Caden's device, onto his iPhone, so I develop on Android. I'm an Android user, I'm a fan of Apple. And so I deploy it to my Android device. When I'm happy, I deploy it to my test devices, my test iPhones that I've got. And when I'm happy, I push it to App Center, Microsoft's cloud resource. In fact, I don't even push it. I do a get pull in or get merge into master, and App Center watches my master branch, and when it sees it, it does a build and it publishes out and sends an email to Cadence to say there's a new update of the software. Sends an email to me, says a new update of the software, and I've got various teams in there. So it's me as a developer, there's a collaborator branch which is Cadence on as a test team, and his mum's on there as well, and they get a push of the app from App Center just by me doing a merge to master. And
it's mad,
take care of it.
Yeah.
It's
like
brilliant.
just that whole CI/CD pipeline of
it's awesome.
I literally push to master, merge to master, whatever. 10 minutes later, it's on everyone's devices.
On everyone's devices, and I don't need to worry about it. I don't need to do a Mac build and get my MacBook out of storage and fire it up to do a build for the iOS. I mean, even now, in the last not even few months, last few weeks, I think, Microsoft and the Xamarin team released Hot Restart, which means that I can plug my iPhone into my Windows machine. And I've had to install iTunes because it uses the iTunes tooling, but I don't need a Mac anymore. So I can build and run and deploy to my iPhone from my Windows machine using Xamarin without ever touching Apple, other than iTunes being installed in my laptop, which pained me to install that. But,
small price to pay.
But it means I don't need a MacBook, which means now when I travel around the world, I can, I've got a little old knackered iPhone that I can just chuck in my suitcase, take with me, and I can check. No, I don't need to carry on my iPhone. Or the way I was doing before was sending the build to App Center and then waiting for the App Center build 10 minutes later for it to push down the iPhone to say, I've missed that bit. And the dev loop cycle was long enough for me to go to the gym and back kind of thing. Whereas now it's literally, it's hot restart and it just works. It's there. And, it's the dev cycle is seconds rather than minutes.
It's amazing,
yeah. Hats off to the Xamarin team for to the guys over there that have pulled this out. It's phenomenal stuff they're doing. So.
Have you been in contact with the Xamarin team?
I was lucky enough to be in Boston a few months ago, and I popped along to the Xamarin offices, or the old Xamarin offices, the Microsoft office now that was in Boston, and met some of the team that went and had lunch with them. Microsoft are taking an interest in the project through all the tooling I'm using. So hopefully they're going to be doing some things with it in the near future. Awesome. As I said earlier, I try and blog about the project, but I've got many blog posts that I've written kind of while I'm flying along, but in gaps in what I'm doing, flying the plane. But I then don't put the images in the right place or the code snippets and things like this, because you can quite easily type a document on your iPad. It's blog posts are coming out slowly on the project, and every time I write it, I go back and look at it and say, no, I've done that now, so now I need to change it. It's hopefully the idea of the blog post is that someone who wants to build one of these will be able to look at the blog posts and go through and see how I got to where I am, but also how to build it themselves. So it'll become almost an instruction manual of how to build your own ARM. So
cool. Yeah, that's amazing. I'm a developer for my. You were saying your sort of full-time paid work is being a pilot, and you do this sort of development stuff on the side, and I do the development stuff full-time, sort of my own, and just like I can't imagine what that must be like. Just you land somewhere, you go to the hotel, presumably you get checked in, and then you go, right, I'm going to spend 3 hours doing development.
It doesn't tend to work like that. We tend to land, go to the hotel and go out for dinner and get some sleep. But you go to the US, Canada, a place like this, your body clock, you're awake at 2-3 in the morning, because that's kind of 9-10 a.m. in the UK. Certainly when you go to the West Coast, like San Jose and a place like this. So I'm awake. There's nothing to do. The gym's not even open yet. It doesn't open until 6 a.m. Get my laptop out and have a little pot of porridge out of my bag and a coffee and start coding. And while everyone else is wandering around and just seeing the sites that we've all seen hundreds of times because we've been there that many times, I'll sit in a coffee shop and code away. Be it working on this handy project or, a client project, doing a Xamarin project, or an IoT project, I'll sit and code away. And because all I need is my laptop and a mobile phone to work on Xamarin, I don't need anything else. It's, I pack light and off I go.
Do you ever get, like you said, then you'll sit in a coffee shop and code away? Do you have Handy with you? Like, do you get people looking and going, what the heck?
I learned fairly early on that carrying that sort of thing in your suitcase means your suitcase gets opened by the TSA.
Oh, of course, yeah.
They want to know, why is there an arm in there? So, yeah, I don't carry the parts with me. I carried, for a while, I was carrying the Arduino Adafruit boards with me, but like the TSA and the authorities, I can't remember what they're called, down in India, see it as an electronic device, wanted to know what it was, and it could cause delays because I was then having my bag searched, I had to explain what it was, the paperwork, etc., etc. So I just don't bother anymore. So for IoT projects, I do work on those at home. I work on the code and have various different branches of ideas I've had that I can't test. And that's another exciting thing about the Wilderness board is the fact that it's .NET.
Yeah, right.
Which means I should theoretically be able to write a console app around it and test the code.
Yeah.
And then when I get back, plug it into the board, and I should have already tested and ironed out, maybe 80 or 90% of the bugs. It's just .NET.
You could. It's a console app that's running on your machine, not running on the hardware. Yeah. And then perhaps you could have someone who's back home who's willing to just plug it in. Just do me a favor, run this command, and it will download it onto the device.
Yeah, my family have gotten wise to that because we've made too many smoke generators in the past. Okay. So it's to the point where my kids joke about the fire extinguishers in my office. It's like, what are they for? Then when they're pointing out that they come and show their friends the handy projects. Yeah. So why are the fire extinguishers? Oh, it's because Dad sets lights to things. So, but I'm hoping that at the point where if it's just .NET, I can write a console app around it, use the same code, and have like a test project where I can test my code, see that it works. And instead of blinking the LED on, I have a print statement that prints the screen, LED on, LED off. And it's a bit, Heath Robinson, it's a bit basic, but it will do, get me to where I need to be. So when I do get back to the UK and I can plug into the board and load the code.
Just drip that UI off and it.
Yeah, and I should be at a point where, as I say, 80-90% of the work is done, and it's just finessing for the board, and it's all C#. So you can then do things like write a test suite around it, which you can't do with Arduino, well, not very easily anyway.
Or if because it's open source, you could push to a testing branch.
Yeah.
Some collaborator can go, I'll pull that down and I'll try it on my Wilderness board I have in front of me.
Yeah.
This LED's come on, that LED's come on, this didn't work. I've got this report, maybe, I don't know, maybe you can hook up a small screen to it or with a hat or something, or just read the GPIO or something.
Yeah.
Hey, I've got someone who's on the other side of the planet who's awake at the same time or will be awake in the next few hours, can try it out for me because it takes 5 minutes. Yeah. Give me a report sorted.
Yeah. Yeah. Well, I mean, even the fact that I hope is that I'll be able to still link it to the Xamarin app. And use the Xamarin app instead of a screen plugged in. Use the Xamarin app as the screen. Screen share.
So diagnostics mode.
Yeah. So, and it will report back to that. I have that working with the Arduino board at the moment, but having a test suite where you can test and build out, just like you would do with any .NET Core project. Being able to test your code. I've made this change and it's broken my test. Right, well, the change wasn't good. Whereas at the moment, you make the change and it breaks and the hand doesn't move. It's like, well, now what? Is it a software fault? Is it in the Xamarin? Is it in the code, the Arduino C? Or is it the fact that I've been bending that wire so many times it's now broken off? As happens every now and again. You look at the wires, that's broken off, that'll be why. And you have to go and get your soldering iron out and solder it back together again. It's been a fun project. I've certainly learned a lot from it, which I think is what everyone likes to do with their sidekicks.
Of course.
And they're things that I've taken back to, the paying customers when I'm doing that. I've got the advantage of the fact that the day job pays the bills and the software stuff is fun. And it's enjoyable to do and get to come to conferences like this.
Of course. Yeah. But everybody benefits, right?
Everyone benefits and hopefully there'll be a few people that will benefit from the project.
Yeah. So. Awesome. So where can people go to find out about the project? Is it just follow you on Twitter?
Follow me on Twitter. I'm quite often posting with the hashtag handy. It seems to be what it keeps getting called, so it's kind of stuck now. My blog and my GitHub are where you'll find the resources. You can download the code, come and jump in with PRs. If you see something I'm doing that isn't quite right, jump in. I'm quite open to feedback.
Awesome. Okay. I'll put all those links in the show notes for sure.
I'll share those with you.
Hopefully we can get some people submitting pull requests and accelerating the building up the agility of the project and getting out new features sooner, and that would be awesome, wouldn't it?
Yeah, it would. Yeah. And as I say, I've kept the Xamarin project as simple, lightweight, and as I possibly could. And the reason behind that is I think a great kind of resource to look at a project that is actually being used, is in the world, rather than it being a demoware app. It's an actual app, but it is as simple as I can make it, so that people can put it. And if you want to learn Xamarin, you're a .NET programmer, you're writing .NET Core and stuff like that. The jump to Xamarin and putting it on mobile is not very big. It's not very big at all. It looks big and scary, and thinks, I've got all the CI/CD of getting it onto. Just throw it at App Center and let App Center worry about that. Download the tooling that's part of the Visual Studio. I even use Visual Studio for programming the Arduino board. Instead of using the Arduino IDE, which if anyone's used it will probably be bored from pulling their hair out. It's not brilliant. VS Code uses the Arduino IDE under the hood. So again, you've got VS Code and the loveliness of VS Code, but you've still got the Arduino IDE issues, as I say. Whereas Visual Studio, there's a fantastic tool which is free called Visual Micro, and it's on the extensions plugins for Visual Studio. Download that, install that. The paid for version just stops it popping up every 5 or 6 times you open Visual Studio and give you a message, please buy me. I think even the paid for is not much. We're talking £50, and it's an awesome tool. So I stay in Visual Studio and I develop the Arduino C, and I can push to the Arduino boards. And then, because it's not the Arduino IDE, I get back my F9 debugging tools, which is amazing. I can put breakpoints, and what happens is when it hits a breakpoint, where you put a breakpoint and you rebuild and republish to the board, what it does, it puts a little while loop in there. So when it hits that breakpoint, it waits for a command back from Visual Studio, say carry on.
Right, okay.
Very clever idea.
Yeah.
So it just sits there in a while loop, and the board just runs.
No hopping and just doing nothing.
No hopping, doing nothing. And then, but you get the breakpoint, and then when you hover over as you do in Visual Studio, it's reading the memory locations. So you get all your tooling back that you know and love.
Debugging.
So your F5, your F9, your F11 is all there. All from this, I'm sure it's £40 or £50. It's not a lot at all.
That's awesome. For Visual Micro, a great extension, and it means that I'm used to the keystrokes, and as we all are using Visual Studio, and it's all there. And I'm away from the IDE. I want to install a library; it does it for me, rather than the Arduino IDE. You've got to go and find it and install it and put it in the right place. Visual Micro managed all that for me, and I don't need to worry about it. So, that's awesome. I like that.
It's cool.
But then pretty soon it might be .NET across quite literally the whole stack.
Yeah, the whole stack. Yeah.
And then it's like .NET runs on the phone, runs on the browser, runs on the server, runs on a hand. Yeah. Like that is a sentence that 5 years ago would not have made sense. 10 years ago would not have made sense.
Well, a year ago wouldn't have made sense.
Well, yeah, exactly. Right.
The Meadow board is literally, it was kickstarted, and I think we all got our boards kind of tail end last year, November, December time. And my talk to come to NDC was the fact that I was going to have .NET running the hands, but because their firmware stack hasn't quite got to the point where I can use it, it's not, sadly. Sure. But hopefully in the next, some point after March when they release this beta 4, I'll be able to put it .NET everywhere, and then in the future be able to talk a bit more about the .NET stack, all of it. I think the only bit I'm missing is the cloud. I suppose App Center is the cloud, isn't it?
Yeah, so, right, there you
go. I suppose someone from Microsoft come and tap me on the shoulder and say you need to put an Azure function in there or something. Someone will think up some way of needing that, but at the moment I don't think we're using that, but
you could use an Azure function to push the update to the phone, which then pushes the update to the hand.
Oh, there you go. You should work on Microsoft in their sales team. So, but it's a great project. It's been fun. I've learned a lot, and most importantly, I put a smile on Caden's face. And when I gifted the early version of the ARM for his 15th birthday, I literally pitched up on his door. His mum knew about it. He didn't. And he opened the box and see this ARM, the look on his face, the smile, the little kind of giggly screen that he made. He's like, I've gone, look at this. This is cool. Look how cool it is. That was worth more than any money they could have given me for doing this.
Yeah.
I've done it all off my own back. Any money that's been put into it has come out of me funding it, so the family don't have to run the costs. So a lot of this has been me, trial and error, and they shouldn't bear that cost. So,
of course. Yeah.
But hopefully, once I've got it complete to a point that I'm happy that others should build these, there'll be a full bill of materials. These are all the parts you need. These are where you buy them from. Other than a few parts, they're all kind of easy to get from the likes of Amazon, RS Components, Adafruit, those sorts of things. A couple of components where you have to go to specialist suppliers, but they're like these springs I mentioned earlier. That I'm looking for a different version that will do the same job, and either to make the price cheaper or to make it easier to obtain. So you don't have to wait for 2 weeks lead time for a part to come from the other side of the world.
Of course, yeah.
But and that'll be hopefully at some point in the next few months we'll get to that stage, and then people can start building these themselves and have a little arm hand that sits on a desk and moves around for them.
Awesome.
So yeah,
it's a brave new world. I love it.
Yeah,
I love it. Excellent.
And it's all built on .NET, or will be soon.
Yeah. So. Well, thank you ever so much for talking with me. This is it's an amazing product. It's an amazing product. It's an amazing project. Also.
I never plan to sell this. I'm never going to sell it. It's always going to be free, open source, and for people to download. If someone doesn't have the skill set to build it, download it, or doesn't have a 3D printer, contact me on Twitter or email. And I'm happy to help out. If you just need the 3D printing done, let me know, and I'll 3D print you the parts. And then you can do the rest yourself, or you're not very proficient at soldering. Let me know, and I'll solder the board together for you, and we'll collaborate and do it that way.
Or indeed, you could build up a team of like if I know I'm no good at soldering, but I can go to someone I went to uni with who did electronic engineering, and I can say, look, can you do me a favor? It's a couple of hours, but can you solder this stuff for me? Yeah. And they'll go, sure, done. Call in a bunch of favors.
So I mean, them sorts of skills like the soldering, the electronics, the wiring. I got taught in my apprenticeship when I was at Ford Motor Company. So I did electrical engineering, but half of that was electronics as well. So we got taught how to do, find skills of doing soldering, desoldering, using solder wicks and stuff like that. So we spent weeks, if not months, learning to solder. And them skills that I learned then are now coming back. It's like when you learn trigonometry at school. When am I ever going to use this, sir? Whereas now it's actually, I'm using it. It's kind of cool. So
awesome.
Yeah.
Well, excellent. Thank you. Like I said, thank you for having a chat. And I'll see if I can get as many people to click through and figure it all out and help you out in some way. I'm sure somebody can help some way.
Yeah, someone with machine learning skills.
Yeah, that's it, right? That's it. We'll have to start poking people as we walk around. Hey, do you know machine learning? Do you know machine learning? And get them all to help you out.
Cool.
Awesome.
Excellent. Thank you very much.
Thank you so much. That was my interview with Clifford Aguis. Be sure to check out the show notes for a bunch of links to some of the stuff we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Limited.